Virtual Reality Reconstructions, where we explore the latest advancements in technology and bridging the gap between science, innovation, and justice. Today, we're honored to have Russell Boynton, a seasoned expert in crash reconstruction, forensic documentation, and 3D laser scanning. They distinguished careers spanning over 4 decades, from the services of the U.S. Marine Corps military police to his tenure as a police officer in the Northeast. Russell is dedicated to his expertise to revolutionize forensic investigations. As a senior field application engineer with FARO Technologies, he trains and supports law enforcement professionals across the U.S. in using 3D laser scanning technology to document crime, crash, and fire scenes. With extensive courtroom experience as an expert, witnesses, and have a passion for forensic education, Russ brings unparalleled insight into the evolving world of crash reconstruction. Russ, welcome to the show, first of all.
Thank you, Ryan.
Great to have you here. And we'll just kind of jump right into it and open up a conversation with some of your background so the audience can kind of know you. And can you take us back a few years in your forensic investigations? Let us know kind of what you do as an expert, and then what sparked your interest in getting into this reconstruction business in general?
Yeah, it's a long story. I'm an old guy, Ryan, so it might take me a few minutes. But no, my dream as a child was to be a police officer. So I actually joined the Marine Corps so that I would have a better shot at becoming a New Hampshire trooper. So I was hired by the New Hampshire State Police after a stint with the local police department. I was hired as a trooper, and during that time, after going through my probationary period, spent a lot of time that is doing motor vehicle crashes. The reason I was recognized on the state police as someone that they might want in the crash reconstruction team was because I had an architectural background, a drafting background. So my diagrams that I would submit were let's just say, tenfold better than what most troopers were sending their supervisors. So as luck would have it, I was invited to join the team. I received my training, my ad scene, my advanced courses, and my reconstruction training as a New Hampshire trooper. And then fast forward several years, about 14 years, I left the state police and took a job as a full-time reconstructionist on the seacoast in New Hampshire, doing private consulting, and received a whole lot more training from motorcycle crash reconstruction, pedestrian crash reconstruction, and then commercial vehicle crash reconstruction. And my favorite of all of those was pedestrian cases. That's still my favorite today. That's how I got started. How I came to FARO is sort of another story. I had a crash data retrieval conference in Texas, and showing some of my animation work to the guys that were at the FARO booth. I was not familiar with laser scanning at the time, and they asked me if I wanted a job, and that was 9 years ago this month. So I've been with FARO Technologies for 9 years. I started out as an account manager, and then I hated sales, to be honest with you, and then jumped. I was asked to I could do something else, and that was to do some training work with FARO, and I jumped all over that. And so I'm still training to this day and enjoying every minute of it. That's a long story. There's more than that, but I'll keep it short.
Yes. No, it's an interesting parallel to me personally, meaning I got into the law enforcement with my engineering and construction background, technical interest, right? Most cops don't have. It got me into the crash and crime scene, doing those being detailed, and like you're saying, drawings. Nobody wanted to do that, right? So camera and the sketch always got handed to me, so I just developed on that. So it was interesting, but yeah, it's definitely a big part of this job we do as a reconstructionist, right? Do it is we're both been in it long enough that we started out in 2D. 3D wasn't there yet, so we both witnessed that and joined it. So that's an interesting parallel.
I usually start my classes, Ryan, asking how many of you in the classroom like to do diagrams. And usually a hand doesn't go up. And if a hand goes up, that's usually the geek of the crash reconstruction team who really enjoys doing the diagram part. Most people don't. And that's where FARO comes in, actually.
Yeah.
You know, and laser scanning comes in a huge way.
Yeah. So on that topic, kind of describe what you witnessed on documenting the scenes and some of those things going from what we started as in our career and then what now you're getting into the 3D side of it. Kind of give us a synopsis of that.
Yeah, I do hate to sound like the old guy, but I am. And you're right. And we started out, you and I both started out, pulling tapes in the field. I mean, I live in and have worked in the Northeast. And so, pulling it in the slush and the mud and the snow and the ice is not a fun thing. And it took forever. So, and we're usually working in extreme either heat or cold conditions. And I remember heard about this thing called a total station survey instrument. And I believe that the state of Washington was one of the first, I might be wrong on that, but one of the first, it might have been Washington State Patrol, that was one of the first in our country to implement the use of total stations. And I remember trying to get some money through the highway safety grant as a trooper, and it was shot down. So New Hampshire unfortunately has a tendency to be a little behind the curve on some of the technology. At least they were then. Let's say that they're not so much anymore. And then, so I finally, as a private consultant, I bought my first total station instrument. I've owned two over the years. And it was like a groundbreaking moment for me, because now we were able to capture really accurate from our scenes, and that we couldn't really do as efficiently when we were pulling tapes. Fast forward now to me being at my crash data retrieval conference in Texas, where I was showing off my animation work. I didn't know at that time what a laser scanner was. So now today, of course, I own my own laser scanner. And FARO also issues me a laser scanner that I use for demonstrations. And I will tell you that there's no way I could go back at this point. So that's kind of like then, and here we are now. And the reason I can't go back, Ryan, is because of, at the end of the day, the deliverables of the exhibits that I get from using a laser scanner device are just phenomenal. So for the people who are not artists, who are not draftsmen or not animators, and really hate to do measurements in the scene, in the field, this is a game changer for them.
Yeah, great point. I know I've been through that evolution as well, and just the idea that drawings and sketches, I could make those as elaborate as you could, but what we're seeing today in the interaction potential is just head over heels of how we started our business. But it's a good thing, right? I know in our area, I don't know, when I was in the field working cases for law enforcement deals, using scanners are being complete because we didn't leave the defense much to fight. So if they couldn't fight the blood test or the intoxication itself, they were left in a struggle. We saw a lot of that. You may have seen it as well, but it was very thorough. Our concept was we had 4 or 5 agencies that were similar in size, but we all worked the same strip of highway. It just extended it to the next city. And so we started joining forces doing these cases. Most of our major cases and deaths, intoxication, were up on the freeway, and we were all doing the same types, right? So we just started teaming up and doing the same and centralizing our investigation. So everybody did the investigation with the same checklist. We got the same data. Everybody checked tire pressures, and we pretty much, you could go to one of those cities and we would work the case, and it would be all just like you worked it in your own, right? So we standardized it. A lot of that helped because we got the experience and knowledge, and you weren't always the lead person or responsible, which makes a big difference. I know for us it did, especially that learning curve, right? Trying to figure out what to do. So, in your background, you had the state and federal background, military and civilian police or state side police.
Yes.
What is that your interaction in Kosovo and Afghanistan? How has that changed or impacted your forensic investigation knowledge and how you approach things here?
Yeah, I mean, mostly my time in Kosovo, which was back in 2003, I was working with a colleague, a retired trooper from Maine, and we were responsible. We were hired to teach basically an advanced collision reconstruction class to the Kosovo National Police, or KNP. We discovered quickly that their mathematical skills are a bit behind where we are. So I mean, it really, at the end of the day, it turned out to be a class on just basic and a bit of more technical reconstruction work, or I should say investigation work. I was amazed at, well, first, they were like sponges. We couldn't give them enough information. They were very excited about what we did, and a lot of the stuff. I remember doing a class on painting with light and photography, and they couldn't understand. I mean, they couldn't believe the results of what we were getting by painting with light over there. And it was like, I was a Martian from Mars or something that came in to show them this really cool stuff. We had been doing that for a long time. My time in Afghanistan was really not crash related. I was a police mentor and advisor embedded with the military, the U.S. military. It was an interesting time. I was there as a former Marine with a bunch of Army guys. So, we had a few good times together. But, a lot of it was, my job then was to just really roll with the military and then go out and teach basic democratic policing to the Afghan National Police. So, yeah, it was an interesting time. It was a rewarding time, but, it's sad to say, I think a lot of that, of what we did there is no longer in place. So, and I'll keep the political side off of it, but no, it was a really interesting time for me. I was there for about 2.5 years working for the State Department initially, and then the contract switched over to the Department of Defense. So not a lot of crash stuff, although I was asked to do a couple of crash investigations involving some of the teams that were rolling with the military out there. There was a lot of bicycle traffic there. There's a lot of vehicles there. And I'll just say it, that people don't know how to drive in Afghanistan. It's not like they're on the highways in the United States. So there were a fair number of collisions involving our own people and the military people. And I was asked from time to time to work on that, but that was not my main objective there.
Yeah, interesting. Well, it's interesting. You got to be able to do that and see the differences like you were seeing, right? And you talk about differences. Let's talk about this. I know for me in law enforcement, the 20 years, the evolution was from an investigator supplying a lot of information and maybe a minimal speed to a prosecutor was probably the first 5 to 8 years, and the rest of it, we were expected to take the next step and be the expert in everything, right? Behavior, ready for the DUI intoxication results, and work it to not only time and distance, but speed and all those factors, and testify as an expert, not just testify to what we found as evidence. Did you see that kind of process as well when you were in the field?
Yeah, I did. In fact, you and I have talked about this in the past. I mean, I sort of have gone in the direction, you have to keep up those classes and stay current, if you will, and things are constantly changing. I started spending more of my time learning about the three-dimensional aspect of the job and being able to create three-dimensional exhibits and symbols and models and animations. And so part of that was I also dug into briefly, because of a time constraint, the virtual reality aspect of crash reconstruction, which I believe is it's on the horizon. I'm not sure how long that will be. I know that there are still some challenges with getting that into the courtroom. I think is probably the biggest challenge. But it's there and it's accessible to anyone. I got my XR development certificate from Unity. XR is that means augmented reality and virtual reality. They're two different things. And then I started digging and playing with another virtual reality free software called Unreal Engine. It's used for the Epic Games industry. Both Unity and Unreal Engine are free. If you have spare time and you want to go out there and start developing some virtual reality or augmented reality projects, it's there It's there and it's readily available to people. The tough part with those two is to make it forensic. In other words, just don't show what you think looks cool or might be something that boosts your case visually. It has to be, as you know, Ryan, to get that into the courtroom, it has to be a forensic demonstration. And that's where a lot of the harder work comes into play here. Is you need to make sure that everything you're doing is scaled, that everything is correct, that everything is visually or scientifically correct. So that's where I've kind of drifted. In addition to that, I took a photo modeler certification course. Photo modeler, for those of you that don't know, I mean, it is really a photogrammetry tool that you can use. Photogrammetry is, of course, obtaining measurements from photographs. And the reason I did that is kind of harkening back to what you asked me, we were doing, the days of old and what we're doing now. I mean, I'm just going to say it for the record that police do a horrible job in a lot of cases at capturing measurements at a crime scene or a crash scene. And I'm not saying that they do it on purpose. I'm saying that they're just not, all police officers are not trained properly or thoroughly enough for them to know when they get to a serious crash scene or a crime scene, just how to take really good measurements and how to document those, which is where the laser scanner comes in, but that's in a minute. I went into the photo modeler software world because I, as a private reconstructionist, would receive cases all the time where I was asked to do, let's say, a speed analysis from skid marks that I could see in a photograph, but that the police never measured. So I was then able to take those photographs and go back out to the scene and take some known measurements in the scene and scale those images correctly in Photo Modeler and then determine what my speed was. And so now that technology has even advanced today to the level where you can take photographs of cars and, determine crush depth from photographs, and you can determine speed from video, from camera recordings. So it's really come a long way. Just really good stuff, exciting stuff.
Yeah, it is. It's sometimes it's almost, even being able to do it full time, it's almost mind-boggling to try to keep up with all the changes and potentials and what ifs and what options do you have. But that's a good chance. We'll kind of switch, but focus on right now with your FARO as a senior application engineer. In your training, and you have 3D laser equipment and their tools, the software tools, what are key benefits of using a laser scanner and crash and crime scene documentation that you found?
No, that's a really great question. I'll put on my sales cap, even though I'm not in sales anymore. And what we say when we do a demonstration of the equipment is absolutely true. It's not a bunch of hogwash stuff. I mean, from the administrator's perspective in a police agency or a large agency doing crash reconstruction, it's the speed of the laser scanning that's really probably the biggest things. It's going to shorten dramatically the amount of time that you're going to have to spend on scene to collect measurements. That's the big one. And so the scanner currently, the older scanner, the S series scanner, captured about 976,000 data points per second. The newer scanner, the premium scanners, well above that. So the amount of data that's coming in real time is just unbelievable. That's the big thing. The other thing is officer safety. If you think about when we were pulling tapes or using a total station, we were always in the road. We were always crossing the street, trying to get to a point that we needed to measure with an instrument. And now the laser scanner can do that from quite a distance. The latest scanner now has a range of 400 meters. The smaller unit is a range of 70 meters. So I believe the new version is going to start out, I might be wrong, I believe it's 200 meters. So the smallest scanner unit would be 200 meters. And that's going to allow officers to stay, or even a private reconstructionist, to stay off the road and take the measurements they need, even across the interstate from the side of the interstate, as opposed to moving back and forth. Another thing is and this is a big one for me, because what I see all the time working in the private sector is when I get information on a case, there are usually measurements that are missing. More often than not, there's data that I wish that I had and I just don't have it. And so a laser scanner is indiscriminate. It doesn't care whether you need the measurements or not. It's going to take them. So what you may not have thought of as being important to your case when you were out there, later it might become important. And as long as you've scanned, your scanners can see it, it's going to capture it. And you now have that information available, and at your fingertips for use later on. And I would say last, there are a lot of advantages. I guess the disadvantage is it's not inexpensive. There is a cost to having the latest and the greatest technology. So that's something that you would need to, as an individual or an agency, look at and see if it's in your budget, and if it's something that you would utilize enough to really, at the end of the day, have a return on your investment. Your return on your investment as an agency is that you're saving money on overtime. And the big one for the motoring public is that you're cutting down the amount of time that you have for road closures and interference with the regular flow of traffic. The final one, which is my favorite, is, let's say that I hate doing diagrams, which, by the way, I love doing diagrams. I hated doing diagrams. I was horrible at it. I was trained in using computer-aided drafting software, but most people are not. So how do I get a really great-looking two-dimensional or three-dimensional model or diagram of my scene if I don't have any training or experience doing it? Well, in this laser scanner world, that's all done automatically for you in the software. You're able to create scaled two-dimensional images. We call those orthomosaic or ortho photographs. And you're able to do 3D point clouds, a three-dimensional model, if you will, of your data points that looks, at the end of the day, if you scan correctly, like a photographic, a three-dimensional image of your scene. So there's all sorts of really cool tools that are available to you in software that it's pretty easy to use, even if you don't have a lot of time using it. Animation creating using 3D point clouds from laser scanners is a really growing industry in our world. I can now take EDR data from a car, and I can take that EDR data and put it into the software, and that crash is animated for me in real time. And that's something I use quite often.
Yeah. You got some great points. I think one of the things I saw, and you may still be seeing it, is the impact of getting that info to the district attorney and judges and how they interpret it and read that as far as concept. I remember trying to walk them through, what is this telling us? What is it? How does it help? What is the plus on this? And what's in there for that to help them understand that concept. So that was, I used to get calls from officers. The judge didn't understand it, or he just wants a printed version of this. And I said, man, keep them away from that. It's just, if they can view a video on a screen, which most people can, they can look through these crime scenes. So yeah, I think great points.
Yeah, you're right about that, Ryan. And I think the most difficult part about using laser scanning technology today is that we need to spend more time educating our prosecutors or the attorneys that we're working for. Right now, we're in a I'm going to call it a grace period, where we can maybe get away with things in the laser scanning world that maybe 5-10 years from now we won't be able to get away with, because most defense attorneys, most opposing attorneys, don't even know what laser scanning is or what a point cloud is. So there is a little bit of flexibility right now. But what I have seen in my travels across the country and teaching abroad is that there are a lot of prosecutors who are still looking for that black and white line drawing that we all hate so much to produce. And that's okay if that's really what they want, as long as they understand that, well, there's something even better than that. And let me show you what that is. How easy it is for you later to take measurements from that, because black and white drawings, it's limited by what you put on the paper, whereas an orthographic photo from a scaled image of a 3D scan is everything, including color if you want it. So there's some work to be done yet for crash reconstructionists or police officers to educate the attorneys they're working for, to let them know what that is, and also not just what it is, but what the possibilities are. Because I can, for example, and I know that we've talked about this before, Ryan, what are some of the things maybe I'm jumping ahead too much, but what are some of the uses of this that, what were cases that I've done where it was put into practice? One example would be, this was a crime scene and not a crash scene, but a young child was shot and killed in the back of a car in Cleveland, Ohio. This would have been about 4 or 5 years ago. The officers did a great job taking measurements of the scene, of the shell casings, of the projectiles, and so on. And what they didn't do was they didn't use trajectory rods in the back of the car. They didn't measure where the car was in the scene, but they fortunately did impound the car. And a while later, they discovered there was video of the shootout between two gangs, one standing on the street corner and another one coming down the street in a car. And the question was, who shot the round that killed the girl? And we went, my manager, Brenda Butler, and I went out to the scene and scanned the scene a year to the day later, and then scanned the car, which was impounded about 10 miles away. And we brought those two scenes together virtually, digitally, if you will. And then we were able to draw those trajectory lines from the car, from the bullets in the car out to the intersection of the street corner, and we identified the shooter in that case. So you couldn't do that pulling a tape. You couldn't really do that well. You could probably get away with it if you were using a total station. I don't want to diss total station instruments because it's another tool in the toolbox that serves a great purpose. I just think it's a little bit easier on using the FARO or just using any laser scanner for that.
Yeah, great point. Study right now on some guys that went back and trying to do the Kennedy shooting, and they're using. They went and scanned it as it is. The buildings are the same. They one of the things that they had to address was, one of the trees has grown vertically, which would have been shorter to the line of sight. Their bullet goes through the tree. Well, they got to explain. Well, that tree was about 6 foot tall when this all happened. So, but anyway, good use of equipment. And once again, we got stuck with that. Do everything right now, right? And you're saying a year later, which things that don't change, the roadway and buildings and stuff, is still a good reference, and we can still accomplish some things with scanners that can help. So you covered
another thing on that real quick, and I do this often. You know how we used to when we have an intersection crash where cars stopped at the intersection at a stop sign, and the other car's coming down from the left or whatever, and then we have the car accelerating the intersection is a crash. Usually it's a line of sight issue, right? Which you just brought up, which reminded me of the way it used to be done. The way it used to be done is we would either put a car down the road at different intervals, and we'd keep moving that car down the road at different intervals until we said, okay, that's where I've lost sight of the car. And then we would go back and measure that distance, right? Okay, that's the distance that the car, it's the furthest away it could be before we lose sight of it. Now in the laser scanning world, we don't have to do any of that. We can take scans of that intersection without any cars in it at all, and then bring in 3D models, scaled 3D models of the cars that were involved in the crash, and put a camera right in the driver's seat and say, okay, look left. And when you look left, can you see the other car at various distances down the street? So all of that work in the field is now no longer necessary.
Yeah, it's great points. And using that technology, I'd love to see this evolution and those kind of things put in place, right? And realizing what you can do. I actually had a similar case on the job where it was officers get their shots fired. They find a vehicle with bullet holes, but nobody around it. One witness says, I heard shots. I looked outside and nothing, right? Didn't recognize the door of a truck was open. So the officers did the crime scene, towed the truck, and about 4 hours later, a body was found down the street in the backyard. Ends up being the victim of the shooting. So now we have another crime scene, but now the truck was gone. And so I had to do the same that you were just talking about, right? Go do the crime scene, go scan the vehicle, and all that information that we have, and reconstruct that to show we were able to show where the suspect was, where the shots were fired. Was able to recover 2 rounds in the front yard, based off of that. So a lot of great information on that. And, it was, there was some time frame in between there. We covered a lot on document with this. Like one thing I'd like for you to talk about a little bit is improvement on accuracy with 3D scanners as opposed to tape. I mean, you got to be really technical about it, but just kind of touch on how this 3D scanner technology is helping us in that arena in the forensics.
Yeah. So, and that's, I guess that's an important part I left out earlier when you asked me what the advantages are. So the scanner, the laser scanner that we sell to public safety is plus or minus 1 millimeter of accuracy, which conversion to imperial is about 1/32 of an inch for your scan data. So thank you for having me too, Ryan. I appreciate the invitation, and this has been really cool.
Oh yeah, not a problem. We'll get those any kind of way to contact Russ. Put on visuals, but his site is at www.FOCAL, FOCAL point forensics, all one together. If you want to check it out. Russ, thank you for sharing your insights today. And to our listeners, if you found the episode helpful, don't forget to subscribe and share. Until next time, stay curious in your forensics investigation. So, Russ, hang tight a little bit. I'm going to close this out, and then we can chat for a little bit.
You got it.
All right. That wraps up another insight of Virtual Reality Reconstructionist. Thank you, Russ Boynton, for joining us today and sharing your valuable insights to the world of advancing crash scene documentation and laser scanning. Thank you to the listeners for tuning in. Remember to follow us on your favorite podcast platform for more episodes exploring the fascinating world of virtual and augmented reality, as well as forensic investigation. Until next time, this is Roger Reinreiter signing off from the Virtual Reality Reconstructionist. Stay safe and stay curious.